Namaste, this is Maulya, studying in Sri Venkateshwara College of Engineering, 7th sem from the Department of Computer Science and Artificial Intelligence. Today I'm going to discuss about the topic importance of processing in IoT, that is Internet of Things, which comes under the subject Internet of Things. Introduction to IoT. The IoT refers to network of physical devices that are embedded with sensors, software and other technologies to connect and which exchange the data with other devices and systems over the internet. There are some key components of IoT. Those are devices, connectivity, data processing, and cloud storage. Some examples of IoTs are smart house, healthcare, agriculture, and industrial automation. All these fields use IoT. And importance of IoT is its efficiency, data collection, and interconnectivity. Next, moving on to data generation in Internet of Things. How IoT devices generate data is IoT devices are equipped with various sensors that collect real-time data from the environment. Actuators may respond to changes in the environment based on the data. There are types of data generated, that is environmental data, health data and location data. In environmental data, it records temperature, humidity, air quality, and pollution level from the sensors. Health data, it records the heart rate, steps, and body temperature from fitness trackers and medical devices. Moving on to the location data, it tracks the GPS data from vehicles tracking devices or asset management system. Moving on to the volume of data, it has a massive scale, that is IoT networks can consist of millions of devices, each generating vast amount of data every second. Continuous data stream involves devices are constantly sending new data points, creating a continuous stream that needs to be processed and analyzed in real time or over time. Next, moving on to data quality and variety. Uh, Unstructured data and heterogeneous data sources come under this data quality and variety. In unstructured data, the data generated can vary in format and may be unstructured. In heterogeneous data source, device may use different protocols, data formats or sensors, making data integration. Next, moving on to the role of processing in IoT. First comes the data filtering. The purpose is that the raw data from IoT device often contains noise and irrelevant information. Processing helps filter out unnecessary data, ensuring that only the important actionable data is passed along. For example, a temperature sensor might collect data that fluctuates slightly due to environmental conditions. Filtering can eliminate these small variations to focus on significant changes. Next, moving on to data aggregation. The purpose is in many IoT applications, data from multiple devices or sensors must be combined to form a comprehensive view. For example, smart homes with multiple sensors aggregate data to create intelligent actions such as adjusting heating based on the occupancy or time of the day. Next, moving on to the data analysis, the other role of processing. The purpose is that once filtered and aggregated, the data needs to be analyzed to extract meaningful insights such as trends, patterns, or anomalies. For example, an industry IoT system analyzes vibration data from machines, and the techniques are machine learning, statistical analysis, and rule-based algorithm are commonly used to analyze things. Next is the cloud processing. Benefits is to reduce latency by processing data closer to the source, which is critical for real-time applications. For example, autonomous vehicle need immediate decision for navigation and safety. So processing is done locally. And when moving on to cloud processing, benefits is scalable and capable of handling vast amount of data. Cloud processing is ideal for less time sensitive data that requires complex analysis and long-term storage. For example, smart city traffic system aggregate data from thousands of sensors, analyze traffic patterns in the cloud, and optimize traffic light cycles. Moving on to the edge computing, the purpose is that the edge computing helps bridge the gap between the local and the cloud processing by performing lightweight processing tasks on local device or nearby edge servers. For example, a wearable device may filter out basis health data locally and only sends critical information to the cloud. And the last role is the decision making and action. The purpose is the processed data derives real time decision making and action, improving automation. For example, a smart thermostat used processed data to adjust the temperature. Now we will discuss about the real-time processing. First we'll discuss about the immediate actions, that is importance of time-sensitive application. Like certain IoT application, they demand immediate real-time response to ensure functionality and security. Example like autonomous vehicle. Autonomous vehicle rely on real-time data from sensors to navigate and to avoid obstacles like accidents. And the vehicle must process the data instantly to make decisions such as applying the brakes or changing the directions. Other examples include healthcare, that is wearable devices detecting a sudden drop in the heart rate but must alert the medical professionals. And industrial automation in a factory setting, IoT system can trigger machine shutdown or adjust operational settings to prevent equipment failure or accidents. Next, moving on to the latency reduction, that is definition of latency is that the latency refers to delay between data generation and the corresponding action. In critical IoT system, minimizing latency is crucial. Need for low latency processing is that the low latency processing ensures fast decision making, especially in a decision where delayed reactions could lead to significant consequences. For example, smart grids and consequence of high. Next, moving on to edge computing. Edge computing refers to performing data processing near the source of data generation rather than sending data to the cloud for processing. Purpose in IoT is the reduced delay and efficient decision making. Example is industrial IoT. In a factory, sensors on machines can process data at the edge to monitor the machine performance and detect abnormalities like vibrations or temperature fluctuations. Benefits of real-time processing in IoT is faster decision and actions, improved efficiency, and enhanced user experience as we discussed in the previous slide. Here on the slide, you can see the benefits of effective data processing in IoT and the challenges that is faced in IoT data processing. In benefits of effective data processing, improved decision making is the benefit, and efficiency and cost reduction, local processing and security. These are the benefits of effective data processing in IoT. Coming to the challenges faced, that is data volume and velocity, heterogeneous data sources, scalability, and data security. These are the challenges that is faced in IoT data processing. Now let's summarize what we have learned. In this presentation, I have discussed about the data processing in IoT and how it is crucial, and role of real-time processing, and how in which fields it is applicable, and benefits of effective data processing and challenges in data processing. And the future of IoT data processing is integration of AI and machine learning, edge computing growth, and IoT's expanding role. These are the future of IoT data processing. Please do like the video. Thank you.